This conference will now be recorded.
Hello. Hello.
Yes, sir.
Audible?
Audible, sir.
Okay, and the screen is visible, no? Okay.
Yes, sir. Screen visible.
Yeah. Okay. Good morning, everybody. Welcome. So, yesterday I gave you some details about clustering. Okay, about clustering, and K means clustering basically. K means clustering. K means clustering. Now, before starting the code in K means clustering, I will give you one simple example. Okay, I will give you one simple example. Let me open the notepad. Okay, this is basically the notepad. Let me open the notepad. Now, just a second. I will actually, all of the students have arrived, na? So it's already 10:35. So हम लोग स्टार्ट कर देते हैं, ठीक है? आस्ते आस्ते हमारे सभी फ्रेंड्स अभी आ रहे हैं, ठीक है? So clustering, K means clustering. So K means clustering में मैंने बोला था आप लोगों को that the value of K will be given. Suppose the value of K equal to 2, then we have to make 2 clusters, right? If the value of K is 3, then we have to make 3 clusters. अगर value of K अगर 10 होता है तो हमको 10 clusters बनाने पड़ेंगे, ठीक है? लेकिन 10 clusters बनाने के लिए हमको उतना data set भी चाहिए, right? So now one thing here, how to make means what to say, clusters, how to make clusters using K means clustering. Okay, so what were the steps? What were the steps in K means clustering? What were the steps? मैं steps जो है यहाँ पर फिर से वापस आप लोगों के लिए लिख देता हूँ. I'm writing the step over here. Just have a look. Just a second. I'm writing the step. What are the applications of clustering? Customer segmentation, document clustering, image segmentation, recommender system. All these are actually the applications, real-time applications basically. What was step 1? The step 1 was to choose the number of K. Choose the number of K, means the number of clusters, and then we need to select K random points as centroids, right? K random points as centroid. And after choosing K random points as centroid, we have to assign all the points to the closest centroid. We have to assign all the points to the closest centroid, and then we have to recompute the centroid of newly formed clustered. Then we have to recompute the centroid for newly formed clusters, and then we have to repeat the previous steps. Okay, then we have to repeat the previous steps. This was what I told. This was what I said. यही बोला था ना मैंने. तो देखिए ये 4 स्टेप्स जो है हमारा, ये 4 स्टेप्स हमारा फॉलो होगा, ठीक है? तो स्टेप 1, सपोज हमारे पास कुछ डेटा सेट्स है. ट्राई टू अंडरस्टैंड द कांसेप्ट प्लीज, ठीक है? ये बहुत ही इंपॉर्टेंट टास्क है, वेरी इंपॉर्टेंट टास्क. K means clustering. Suppose I have got some data set. Something like this, okay? Now I have to यहाँ पर K का, तो what is the thing? K value is 2. K का value कितना है? The value of K is 2. That means step 1. Step 1 is telling that choose the number of clusters K. तो suppose यहाँ पर हमको बोला जा रहा है that K equal to 2 means you have to make 2 clusters. Then they are telling select K random points from the data as centroids. Okay, so since we are going to make 2 clusters, then how many random points we are going to choose? 2 random points. Since we are going to make 2 clusters, that the value of K is 2, and we are going to make 2 clusters, so how many random points we are going to derive from this data set? कितने random points derive करेंगे? 2. Okay, so tell me R1 random 1, okay, और यहाँ पर R2 random 2. So R1 में कोई tell me something, any number, Any number from the data set?
Sir, 5.
5. Okay, 5 random choose, and next R2.
Sir, 11.
11. Okay, chalo. That's it. So I took 2 random points. Right now, I said it works on the distance. So they are telling what? So step 2 is complete. See, step 2 is complete. Now they are telling that assign all the points to the closest cluster centroid. So how we assign any point to the closest cluster centroid? Using the distance formula. Using the distance formula. So here we are going to form 2 clusters, right? Here we are going to form 2 clusters, isn't it? We are going to form 2 clusters. So see, R1, the value of first random point, that is first centroid, is 5. So just take 2. Is 2 closer to 5 or it is closer to 11? Now compute. Let's compute. Is 2 closer to 5 or 11? It is closer to 5. So 2 यहाँ आ जाएगा. 3 किसका क्लोजर है? वो 3 को मैंने दो बार रिपीट कर दिया है. अच्छा, 3 किसका क्लोज है? 3 किसका क्लोज है? 5 का क्लोज है, 11 का 5. तो यहाँ पर आ गया. 4 किसका क्लोज है? 5 का 11 का 5. 7 किसका क्लोज है?
Sir, 5 only because of the distance.
5. 1 is closer to 5. 9, I think it's closer to
11.
11. It's closer to 11. Yeah. Then 20.
11.
11 is closer to 11, and 5 is closer to 5. Okay. So that's it. Done. Now this is complete. Step 3 is complete. Now they are telling recompute the centroid of newly formed cluster. So we have newly formed cluster, 2 newly formed cluster again. तो इसका centroid निकालना पड़ेगा फिर से. R1, and again we have to find the centroid, that is R2. Okay, R2. That's it. So R1, how to find the newly formed centroid? Newly formed centroid. 2 plus 3, 5. 5 plus 4, 9, and 9 plus 7, 16. 16 plus 1,
17, 22.
17 plus 5. What is 17 plus 5, Darshan? I think it's 22.
22. Sir, 22.
22 का इसका मीन निकालिए. 1 2 3 4 5 6. 22 को 6 से डिवाइड कीजिए, कितना आ रहा है?
Sir, 3.6, something like that. 3.6, something like that.
3.6. Can we consider it as 4?
Yes, sir.
Yes. And here we have 9 plus 20 plus 11. What? And add this and divide it by 3. Since we have got 3 number over here, so add it and divide it with 3 and 10.
Sir, 13.33.
13.33 means 13. Chalo, 13. Okay. Again here the value is 4, and again here it is 13. So let's make the cluster once again. Okay. So here 2 is closer to 4 or 13? It is closer to 4. 3 is closer to 4. 4 is closer to 4. Then 7 is closer to 4. 1 is closer to 4. 9 is closer to 4 or 13?
13.
How it is?
Sir, it is 13, sir, because the distance it is 9 minus 4, it is 5, and here 13 minus 9 is 4.
Okay, very good. Then it's 9 will be here.
20 also 13, 11 also 13.
11.
Sir, 13.
11 is closer to 13. 5
is closer to 4.
Now we can see that we are getting the same clusters. We are getting the same cluster twice. The cluster is getting repeated. That means will we continue? Will we continue? No.
No, sir, we will stop.
We will stop over here. Why? Because we are getting 2 similar clusters. That means our clustering is done. The first clustering is 2, 3, or we can say 1, 2, 3, 4, 5, 7, and the next cluster is 9, 11, and 20. That's it. The clustering is done. 2 clustering is done. So this is C. Otherwise, if this has been a different cluster ना, अगर ये line number 19 में अगर हम लोग को कुछ different cluster मिलता है, तो फिर से हम लोग इसका mean निकाल के, मतलब centroid निकाल के फिर से हम लोग इसको compute करते हैं. मतलब step 3 और step 4 repeat होता है. फिर से step 3 और step 4 repeat होता है. ठीक है? So this is how we go for k-means clustering, and this is basically the formula basically. Clear to everybody? Is it clear to everyone? No problem, na? Now, okay. Now, next thing is that while working with k-means clustering, yes, Anand Mohan, हेलो आनंद मोहन जी, आप कुछ बोल रहे थे तो म्यूट कीजिए। आनंद मोहन जी म्यूट कीजिए प्लीज, म्यूट। ओके, नाउ so this was for a small data set. So for a small data set, you are absolutely correct that you might ask a question to me that, sir, this is a small data set. Okay, so we are stopping after one step or two step or three step or four step or maximum 10 step, 20 step, 30 step, we will stop, sir. Okay, means we, after this much steps, we are going to get a similar cluster. Okay, so if we are having a large data set, sir, very large data set, okay, very large data set, so in that steps, in that cluster, means in that those types of data set, sir, how means when we will stop? Suppose if it takes 100 iteration, 200 iteration, 300 steps, 400 steps, 500 steps, 600 steps, so sir, when we will stop? See, what is actually the stopping criteria? What is actually the stopping criteria for k-means clustering? The stopping criteria for k-means clustering is basically if the centroid of a newly formed cluster does not change, then we are going to stop. जैसे हम लोग का ये केस में हुआ, okay? And if the centroid doesn't change, that means what? The points remain in the same cluster as it is. The points remain in the same cluster as it is, okay, and the maximum number of iteration is reached. And if the maximum number of iteration is reached, if these three steps are completed, that means we are going to stop for k-means clustering. Means if the value of k is given for large data set, if the value of k is given also, then the value of maximum iteration will also be given to you. The value of maximum iteration will also be given to you, that you have to go for 100 iterations. Okay, so we can stop the algorithm if the centroid of newly formed clusters are not changing. We can stop the iteration if the points remain the same in the cluster. We will stop the iteration if suppose we are told to give 100 iterations for the data set, 100 iteration. So once 100 iteration is repeated, okay, we are going to stop. So these are actually few things. Got it?
Yes, sir.
No problem, no? Now before diving into the code, I would like to suggest you few terms over here while evaluating clustering or different evaluation using clustering or k-means clustering we have in here. Okay, so you have to keep certain things in mind. The first thing that you have to keep in mind is inertia. Few terms. Inertia is the term that you have to keep in mind. Now you might be asking, sir, what is inertia? Okay, and what does inertia evaluate? It basically tells how far the points are within a cluster. This is basically called inertia. Confused? Let me explain. I will explain this thing to you. This is the most important task, or we can say the most important part that you need to understand. Okay, getting the point. Wait, let me share a tutorial. Okay, just have a look at this tutorial. Can you see this Word file? Yeah. So inertia What is inertia basically depicting? Inertia. Recall the first property of cluster we covered. रिमूव कर दीजिए क्योंकि इसका मैंने देखिएगा कल मैंने आप लोगों को एक ट्यूटोरियल दिया है क्लस्टरिंग का. रिमेंबर आई गिव यू वन ट्यूटोरियल ऑन क्लस्टरिंग. So
Yes,
what actually inertia evaluates? What actually inertia evaluates? It tells us how far the data points within the cluster are. So inertia actually calculates the sum of distances of all the points within a cluster from the centroid to that cluster. So if this red dot is actually the cluster or centroid, if the red dot is centroid and all these square boxes are the data points of that particular cluster, so all the distance calculated, sum of all the distance or the sum of the distance of all the data points from that cluster within from that centroid within that cluster is termed as inertia. So we calculate this for all the clusters and final inertial value is the sum of all the distances. So this distance within the cluster are known as intra-cluster distances. This is called intra-cluster distances. So inertia gives us the sum of intra-cluster distances. Intra-cluster distances. Just have a look and tell me, is it clear? Intra-cluster distances. Okay, now what do you think should be the value of an inertia for a good cluster? Is the small inertial value good or do we need a larger value? We want the points within the same cluster to be similar to each other, right? Hence the distance between them should be as low as possible. क्योंकि जितना distance ये data point का centroid से कम होगा, that means what? The data points are associated to that centroid so much, means it actually calculates the smallest distance. No, means it should be, the distance should be smallest, not largest. Largest distance means the points are quite far away from the centroid, and shortest distance means the points are very close to the centroid, very close to the centroid. Getting the point? Okay, so keeping in mind, just have a look, keeping in mind, we can say that lesser the inertial value, the better are our clusters, right? Better are our clusters. Now the next is the Dun index or Dun index, whatever you say, Dun index or Dun index, whatever. So what is actually the Dun index? We know, okay, we know, or we now know that inertia tries to minimize the intra-cluster distance. Means it is trying to make more compact clusters, more better clusters. Let me put it this way. If the distance between the centroid of a cluster and the point in that cluster is small, it means that the points are closer to each other. Very good. So inertia makes sure that the first property of cluster is satisfied. But it does not care about the second property. It does not care about the second property, that different clusters should be as different from each other as possible. ये हमारा second property है. Different clusters should be as different from each other. This is where Dun index came into action. ठीक है? So देखिए ये इंट्रा क्लस्टर डिस्टेंस है और ये डिस्टेंस बिटवीन टू डिफरेंट क्लस्टर सेंट्रॉइड्स इज कॉल्ड इंटर क्लस्टर डिस्टेंस. Inter cluster distance. Along with the distance between the centroid and point, the Dun index also takes into account the distance between two cluster centroids. This distance between the centroid of two different clusters is known as inter-cluster distance. Let's look at the formula of the Dun index. देखिए, Dun index equal to basically what? What is Dun index telling? Dun index is telling that, okay, Dun index is telling that minimum of inter-cluster distance upon maximum of inter-cluster distance, intra-cluster distance. This is basically what Dun index is. So Dun index बोल रहा है कि it calculates the distance between the centroid of two different clusters. Centroid of two different clusters. Getting the point? Centroid of two different clusters. Clear हो रहा है आप लोगों को? What is Dun index or Dun index? Clear? Now again my same question arises that Dun index should be maximum or should it be minimum? Means Dun index का value जो है वो maximum होना चाहिए या minimum आना चाहिए? बोलिए. Tell me.
Sir, if the Dune index value is maximum, then more clusters are present.
Yes,
If
good cluster is present, na? Rohit.
yes,
See, Darshan has told more. Means if the Dune index is more, means two cluster centroids are far away from each other. That means a distinguished cluster is formed. Distinguished cluster is formed. Getting the point? Distinguished cluster is
yes,
formed.
sir.
So more see, they have written Dune index is the ratio of the minimum of the intercluster distance upon maximum of intracluster distance. So we want to maximize the Dune index. The more the value of the Dune index, the better will be the cluster. Let's understand the intuition behind the Dune index. See what they have written. Clusters are far apart. Okay, clusters are far apart. What they are telling? Clusters are far apart, means minimum intercluster distance upon maximum intracluster distance. In order to maximize the value of the Dune index, the numerator should be maximum. Numerator should be maximum. Here we are taking the minimum of intercluster distance. So the distance between even the closest cluster should be more, which will eventually make sure that the cluster are far away from each other. Because agar denominator zyada ho jayega, if the denominator is more, then we will get lower number, na? And if the numerator is more than denominator, we will get a higher number. Yes or no? So this is what basically Dune index is actually telling. Okay. See, max intra-cluster distance means the clusters are compact. Compact means बोलते हैं ना कि मतलब compact मतलब एक जगह पर cluster सही में लग रहा है कि yes, it's clustered. Clustered. Okay, clustering है basically. माने छोड़िए जवान में. Okay. So the denominator should be minimum to maximize the Dune index. Okay, so here we are taking the maximum of intercluster distances. Again, the intuition is the same here. The maximum distance between the cluster centroid and the point should be minimum, which will eventually make sure that the clusters are compact. That's it, what we call Dune index. And this is how we calculate Dune index. Clear? Is it clear? If the theory is clear, then I will go to the coding part today. Okay, very good. Now let me start the coding part. Okay, let me start the coding part. I will give you all this. Okay, so if we take into account the iris flower data set, see, I have performed using the iris flower data set. Okay, iris flower data set. Okay, iris. Where is iris flower data set? Iris flower data set. Iris flower data set. Iris flower data set, right? This is actually the iris flower data set. So how many classes are there? 3 classes, no? Setosa, versicolor, and virginica. Okay. Now, if I take this data set, clustering is an unsupervised learning, na? Unsupervised learning. That means this target column will not be present. This target column will not be present. Okay. We are not going to work with this target column. I will drop this target column. This is of no use. This is of no use, right? And here this ID column is also extra column. It is of no use. So I'm going to drop that also. So if I just take sepal length, sepal width, petal length, petal width, these 4 features if I take, okay, without target, how many clusters shall I make? Tell me. मुझे कितना clusters बनाना चाहिए? We know about this iris flower data set. Lot of thing about this iris flower data set. This is very common data set. So if we take this iris flower data set, how many clusters we will make? How many clusters we can make? Boliye, how many clusters can we make?
Sir, 3 clusters.
3 clusters. We know that we can make 3 clusters. We can make 3 clusters. We know we can make 3 clusters. Okay. See, clustering is a very important thing. It's a very means what to say typical thing. It's very typical. Okay, very typical. K means clustering. Okay, that's why I have written the code so that I can explain you well. Okay, I have written this code only. I have written so that I can explain it to you. See.
So I have one question.
Yes, please, Darshan, tell me.
So like here, so sir, we know that we should make 3 clusters because we know about the data set. We know that first we have seen the output. Basically, we have seen the output. That is why we can say that there are 3 classes. So we are making 3 clusters. when
Yes.
if we are getting a type of data set where we don't know anything about the output or the level part, then
Then
how
you
many
will make
clusters we should make?
Yes, how clusters? Remember yesterday I told something about elbow algorithm.
Yes, sir. Elbow algorithm.
I have implemented the elbow algorithm in this particular example. That's why I have written the code so that I can make you understand over here very well. See, writing the code is not that difficult. It is very, very easy. But making somebody understand is it's a very means challenging task, right? Getting the point, Darshan? So,
Okay, sir.
yes, that's why for this clustering code I have already written so that I know that yes, lots of questions will arise after I show the code or after I demonstrate the example. That's why I wrote this code, and today I will explain it to you. Darshan, your question answer is available to me. I will solve your doubt. 100% I will solve your doubt. Okay, don't worry. ओके गिव मी 10 to 15 मिनट्स एकदम बोलता है ना एकदम पानी जैसा क्लियर हो जाएगा एकदम जल जल जैसा क्लियर हो जाएगा জলের মতন ক্লিয়ার করে দেবো একদম দেখো ডাউট গুলো তোমার একদম জলের মতন ক্লিয়ার হয়ে দেখো খালি ফার্স্ট অফ অল here I have taken numpy, I have taken pandas, matplotlib, and this is actually the k-means means scikit-learn.cluster import k-means. You know, because we cannot make the model without scikit-learn. So for scikit-learn.cluster import k-means. So scikit-learn is the package, okay, and cluster is the sub package, and k-means is the module. K-means is the module. So I have implemented this. So any doubt with this first one? I run this. No problem? No. I have read this irish.csv dataset over here. This is also very simple. Reading this irish.csv dataset, you'll say no problem, sir, over here also. Okay. Now I need to drop this ID. I need to drop this ID. So here I have considered the dataset from. I have taken all the rows, but columns I have taken from the 1th column, not 0th column. Not 0th column. I have started from the 1th column. So 1th column. 1th column. Okay, 1th column. See, sepal and sepal with petal and petal with species. Got it? I have dropped this ID column because this ID column is useless. Useless. It is increasing the dimension of the data, so it's useless. I have removed it. Okay, I have removed it. So this is my actual data set now. Actual data set. Now a question might arise that, sir, since this is unsupervised learning, then why you have not dropped the species till now? Why you have not dropped the species? You have not dropped the species. Why, sir? Why you have not dropped the species? So the answer is here. See sepal length, sepal width, petal length, petal width is our feature. So in a variable x, I have taken data.ilog. I have taken all the rows, but I have taken the 0th column, 1th column, 2th column, 3th column. Means 0th column, 1th column, 2th column, 3th column. But this last column, 4th column, see, I have left. I have not taken into account. Okay. So, and dot values I have done. Why I have done dot values? Because I have told you before that machine learning algorithm only understands array, right? It understands array. So I have, if you just do value, it will be converted into array. See, if you do that values, okay, it will be converted into array. Anything. If I remove this value, it will be in data frame format. Okay. If I remove this, it will be in data frame format. Just see, I'm removing this. See, it's in data frame format. Getting the point? Anything you can do, right? So this is a new thing to convert into an array. So you can just take into account this also, or else you can remove this value and you can keep it in data frame format also, no problem. But I have removed this species column over here. See, I have dropped this species column. Now clear to everybody? Is it clear? See, you can yeah, you can see the values of the 5.1, 3.5, 1.4, 0.2. See, 5.1, 3.5, 1.4, 0.2, and see, total 150 records. See, 150 records. Is it clear to everybody? Any doubt till here? No problem. Okay. Now let's move ahead. So I have dropped the species column. Now my data is totally unsupervised. It's totally unsupervised. See, there is no target column. No target column is there. Only unsupervised data I'm taking. Now I created the model over here. See, k equal to k means simple, जो मॉड्यूल है हमारा, देखिए जो मॉड्यूल है वही तो मेथड बन जाता है ना, हमारा मॉड्यूल है k means, तो यही हमारा मेथड बन जाएगा, देखो मेथड बन गया k means ओके। यहाँ पर एक एट्रीब्यूट आता है n अंडरस्कोर क्लस्टर्स, सो वी नो दैट दिस इज आवर नोन डेटा सेट, हम लोग को पता है कि भाई यहाँ पे 3 क्लस्टर बनेगा, वी नो दैट वी विल मेक 3 क्लस्टर, but here I have given a wrong value. See, I have given a wrong value. Is this 5? Is this 5 correct or wrong? Tell me. Is this 5 correct or wrong? It's wrong, because we have got 3 classes in the data set, and you will say, sir, you are making here 5 cluster. Sir, you are making here 6 cluster. Sir, you are making here 7 cluster. See, sir, you are making here 7 cluster. So even if I am making here 7 cluster, okay, and here I am writing k dot fit underscore predict x, inside x I have the data set, and here if I print y, see, it is giving me 7 cluster, man, it is giving me 7 cluster. That means, but I don't know whether it is giving whether I'm getting a correct cluster or not, means whether I'm getting a correct answer or not. What it seems not that everything is going correct, it seems not everything is going correct. Yes or no? Tell me. लग रहा है ना कि सब कुछ ठीक ठाक हो रहा है, हम लोग गलत है लेकिन लग रहा है कि नहीं कि सब कुछ ठीक ठाक है? Tell me. Isn't it looking that yes, it's giving me 7 clusters? Oh my god, I'm doing very nice task. 7 cluster, very good. 7 clusters, I have made 7 cluster, but this is wrong. This is the wrong output. Okay, this is the wrong output.
Sir, is it making the sub cluster also?
Yes, you are right, Rohit. So, and even if I found out the cluster centroid, see, it is giving me 7. See, 1 row, 2 row, 3, 4, 5, 6, 7. It is giving me 7 centroids also. It is giving me, see, it is giving me 7 centroids also. So it is giving me 7 clusters and with 7 centroids. For finding the centroid, there is a constant called cluster underscore centers underscore. That's it. So it is giving me 7 centroid. Now you might be wondering, sir, it does everything is looking fine. Everything is looking fine, but friends, we are wrong. Now here, what comes in elbow algorithm? Here is where elbow algorithm takes entry. Elbow algorithm यहाँ एकदम हीरो का तरह एंट्री मारता है, हीरो का तरह. देखो, this is elbow algorithm. See, in elbow algorithm, I have taken an error. Okay, I have taken a variable, empty list. Okay, empty list. Okay, I have taken one loop. Suppose loop from 1 till 11. You will tell, sir, why 1 till 11? See, I have got 150 data set, right? 150 data set in Iris. So how many clusters maximum you can make? 3, 4, 5, 6, not more than that, right? Not more than that. That's why I have taken here 1 till 11. 1 till 11. So 11 means 1 till 10. This is very, very high loop. Okay, you can take here from 1 till 6 only. That is enough. Okay, and if you have large data sets, now you can go for this loop from 1 till 20, 1 till 30. Because from 150 record in Irish data set, we cannot make more than 3 to 4 clusters, right? Am I right? Maximum 3 or 4 or 5 or 6. Okay, so you take the loop according to that. Okay, you will take, sir, I will take loop 1 to 50. So it's your choice. But making 50 clusters in 150 record is not justified. Okay, that's why I have taken here 10 loops. Okay, 10 loops. Now, just like k nearest neighbor, what I have done, see, I have created the model inside the for loop, and inside n clusters I have passed I, means first the value of I will be 1, means 1 cluster will be made, then 2, then 3, then 4, 10 cluster will be made, and each and every time fit x is fit. So k means dot fit x. Now here the model, the data is fit to the model. Okay, now error is actually the empty list. So inside the error, what is appended? Inside the error, k means dot inertia is appended. See, inertia.
So one question.
Yeah, Darshan.
So why dot fitx twice you have written? Because here also you have written to fitx, and here also fitx.
Which one? This one, no?
Sir, yes, sir. Dot fitx you have written twice. K means dot fitx, and here also k means equals to k means. So whether
you are telling this one, no? So if I run this, You are right. This was actually extra. Yeah, very good. Very good. I have written 2 times. Good. Tick. Very good. Thank you, Darshan. Thank you. So now this is basically the. Thank you, Darshan. Thank you. So I have run here fit. I have fitted the X. Now inside the inside the append method, K means and inertia underscore inertia. Inertia. I told you what is inertia. The inertia is basically appended inside this list 11 times, or sorry, 10 times. Okay. Then I gave a graph plot inside the x-axis. X-axis will plot values from 1 till 10, and y-axis will actually plot the error. Means the empty list inside which inertia is basically appended. Okay. The title for the whole graph is elbow method, and x label is number of clusters and y label is error. I get a graph something like this. See this one is very easy, isn't it? Just have a look and tell me. Any doubt with the code? Any doubt with the code? No. Okay. No doubt with the code. Okay, very good. Now I get a graph something like this. Now you tell me where we have the elbow. Where we have the elbow. Elbow means अपना हाथ ले लीजिए, हाथ, और हाथ का elbow को देखो, elbow, हाथ का elbow देखो, कहाँ है elbow?
The 3, near about 3, between 2 and 4.
Near about 3. Okay, there is a bend at 3, not near about 3, Darshan. Exactly at 3, just have a look. There is a
exactly
bend.
At 3, yes sir. Exactly at 3. It means between 2 and 4.
Yes, between 2 and 4 there is 3. There is a bend. एक bend है ना, वो bend जो यहाँ पर है, ठीक है, उसी bend को हम लोग क्या बोलेंगे? That is the number of cluster that we are going to form. Now, Darshan, do you get your answer? Darshan, did you get question to your answer to your question?
Yes, sir.
Yes, this is basically the thing. That's it. This is what we call elbow method. This is what we call elbow method. This is the elbow method. And here we are having an elbow at 3. We are having an elbow at 3. We are having an elbow at 3. See, 2 और 4 के बीच में एक elbow है. Now we know that I need to. अभी हमको पता है. I know that now I am 100% sure that I have to form 3 clusters. So what I did, I again copy pasted this code. I again copied this code and I pasted it over here. See, and I have formed 3 clusters. See, so nice 3 clusters it is giving. See, so nice 3 clusters it is giving. See, it is giving so nice 3 clusters. See, isn't it looking wonderful? Isn't it looking wonderful? Now,
yes, sir.
Now, if I plot this, okay, I'm getting cluster something like this. See, if I plot this, I'm getting counter cluster something like this. That's it. CMap I have given rainbow. Why? Because it will take color according to its own choice. I don't need to worry about color. That's why color map rainbow. 7 colors. If there are till 7 color, it will take automatically of its own. After that, it will try to give color shades like light yellow, dark yellow, something like that. Okay.
And so C equals to Y underscore K means there are 3 values, 0, 1, 2, that is Y, right? 3 colors.
Exactly. Yes. So C equal to this. Okay. Getting the point? Right?
Can you show the graph? Can you scroll down a little bit?
Yes, I can show the graph. Okay, the plot or the graph?
Scatter. Yes.
Take it.
Sir, like one question. So yes. Like here we can say that the green one, that is a different cluster as it is from the scatter plot only I'm saying, but the blue and the red one, or in the color, it is basically yes. Not a distinct. Basically, it is not a cluster. They are both joined. Some values.
Yeah, I'm telling. See. If I run this thing again. Am I getting some different?
Okay, means color is changing.
Yeah,
Blue
I'm
and
getting
red color is changing.
Yeah, I'm getting some different. I'm getting some different
Yes.
clusters. See, again.
Yes, sir. Different clusters. Green one is same, but the blue and red one is basically
Yes,
almost
because
changing.
green one. You know why? Darshan, this green one is iris setosa. This is setosa. See, sepal length is also very less. Petal length is also very less. I have taken x colon 2 na. See, this one I have taken. So see, wait. What is it? It is 1.4, 1.4, 1.3, 1.5. Let's come here. Let's go. Yeah. 1.4, 1.4, 1.3, 1.5, 1.4, isn't it? So this is basically what? 0,
basically when Virginica
2.
and
It is actually, yeah, it's petal length and petal width. So here, for plotting the graph, I have taken petal length and petal width. Okay, so with the help of this petal length and petal width, it is making cluster. Now you will say, sir, can't we make the cluster with 1 and 2? Can't we make the cluster with 1 and 2? Why not? See? Why not? See?
Okay. Okay, got it, sir.
Getting the point?
Yes, sir.
So this one is this is smaller one this is actually iris setosa. Setosa is a very smaller plot.
Fully different. That is
Yeah,
just
it is
fully different.
because for setosa the sepal length is also very small, sepal width is also very small, petal length is also small, petal width is also small. इसीलिए देखिए सेटोसा जो है ना ये पूरा कोना में है, एकदम कोना में सबसे अलग. But between versicolor and virginica, some points mismatch. Means not mismatch. Means some points are common. Okay, some values contrast. That's why some points are overlapping. Getting the point?
Yes, sir. Got it, sir.
Okay, so here I have made with 2, and if you make 2, then you have to take 3. It's sepal length and sepal width, petal length, petal width. चलो पेटल लेंथ देखो, इससे भी अच्छा क्लस्टर बन रहा है. देखो
Sir, means we can make only with 2. We cannot make all the 4 together.
How we will basically make it a 2D, na?
Okay. Got it, sir.
Getting the point?
So different scatter plots for different 2.
That you can make. That you can make according to your choice. No problem with that.
Okay, sir.
Okay. So that's it. That's it. And if you want the centroids, if you want the centroids or centroids plot करना है, तो centroids लेकर centroid का फॉर्मूला ले लीजिए आप यहाँ से. मैंने centroid का फॉर्मूला भी आपको दे दिया है. अगर आपको बोला जाता है एग्जाम में या फिर कहीं आप इंटर्नशिप वगैरह कुछ भी ये कर रहे हो तो आपको बोला जाए सर देखिए सेंट्रॉइड हमारा यहाँ देखिए सेंट्रॉइड है, देखिए सेंट्रॉइड्स, या फिर एक वेरिएबल में स्टोर कर लो सेंट्रॉइड्स को एक वेरिएबल में स्टोर कर लो.
यहाँ पे तो सर डून इंडेक्स आया नहीं वर्क में.
नहीं, डन इंडेक्स तो आप कैलकुलेट कीजिएगा तो डन इंडेक्स आएगा ना, लेकिन हमारा डन इंडेक्स का तो जरूरत नहीं है. डन इंडेक्स बेसिकली क्या है? सेंट्रॉइड का डिफरेंस, 2 सेंट्रॉइड्स का डिफरेंस. ओके,
अगर हम लोग को इस स्कैटर प्लॉट में जहाँ पे जैसे हम लोग का स्कैटर प्लॉट है यहाँ पे, अगर हम लोग को इस स्कैटर प्लॉट में 3 सेंट्रॉइड दिखाना है, हम लोग कैसे दिखाएंगे? एज लाइक 3 क्लस्टर्स.
ऐसे 3 क्लस्टर्स आप कैसे सेंट्रॉइड प्लॉट कीजिएगा? हियर इज द सेंट्रॉइड. सी आई हैव शोन यू द सेंट्रॉइड वैल्यू दर्शन.
यस सर.
देखिए यहाँ पे सेंट्रॉइड का वैल्यू है. आई हैव गिवन यू द सेंट्रॉइड वैल्यू. ओके, given the centroid value. Now if I ask the same question to you and everybody that can you make it possible, क्योंकि मैंने बहुत कुछ बताया, बहुत एल्गोरिथम्स बताया. How to plot the centroid? My question, very nice question Darshan has asked, but this answer lies to you. You have to give me the answer. Anybody?
please once again repeat the question, sir.
My question, Darshan also said that, sir, how we will actually plot the centroids? How we will actually plot the centroids? So how we will actually plot the centroid? Centroid को कैसे plot कीजिएगा?
Sir, we will find the mean value.
No. Centroid, see, value I have given. The value I have given, see, 3 centroid value I have given. How you will plot it? How you will plot it? That you tell me. How you will plot it? That you tell me.
Sir, scatter plot or some plotting.
Sir, if we will take scatter plot inside and if we will take the function only k dot cluster inside the scatter plot, if we put,
Okay.
and then in the basically we will give the like as you are giving in means यहाँ पे आप जैसे x के साथ दे रहे हैं :0 मतलब पेटल लेंथ पेटल विड्थ, अगर हम वहां पे अगर :0 और 1 देते तो हम लोग का पेटल लेंथ का ही सेंट्रोइड मिल जाएगा, पेटल विड्थ का सेंट्रोइड मिल जाएगा.
ठीक है. Can I expect this graph output in the second half?
ठीक है सर. So try.
Can I expect? Yeah. Can I expect this graph output? It is very easy. It is very easy. It is very easy. आप reference वगैरह भी, you can take reference also from anywhere. You can take the reference. Okay. And I just want to plot the graph. I just need to plot the centroid. यहाँ पर inside this particular thing there will be one centroid. Here in blue, for blue there will be one centroid, and for red there will be one centroid. Okay, and mark that centroid with cross. Yes, please tell me. Hello, any more question? Okay, so can I expect the answer in the second half?
Yes, sir.
Okay. Mohit is telling yes. Darshan, Rohit. No, sir, we can plot this by flattening method. Not required. Flattening is not required. Rohit, Rakesh, flattening is not required. You are going in some other direction, that is not required. Okay.
Okay,
That
sir.
is not
Okay, sir.
not required. Okay, so let me see. I'm giving this. Wait. I'm giving this in the group so that there is no delay. Wait. Okay. I have sent. Hope so. There is no doubt. And if there is no doubt, shall I go for Another algorithm. Okay. Deepi Ranjan saying yes. Very good. आप लोग इसको ट्राई कीजिए, ये अगर आपसे पॉसिबल हो जाता है देन वेल एंड गुड, अदरवाइज क्लस्टर का सेंट्रॉइड प्लॉट करना कोई बड़ी बात नहीं है. आई विल प्लॉट द सेंट्रॉइड. ओके, नाउ स्टोर द सेंट्रॉइड्स इन अ पर्टिकुलर okay, so this is basically the centroid. Got it? Let's move ahead. Let's move ahead. Now, today we'll go for SVM. SVM. Can anybody tell me what is SVM? Support vector machine. What is SVM? Support vector machine. It's a classification algorithm. It's a classification algorithm. It's a classification algorithm. But do anybody have any idea? Darshan, Rohit?
No sir. No sir. SVM के बारे में से नहीं पता.
नहीं पता है. Support vector machine. Support vector machine. It's a very powerful algorithm. Very powerful algorithm. Okay, it's a very powerful algorithm. Support vector machine. Support vector machine is basically, it is used for classification. Okay, it's used for classification. It's used for classification. Okay, so support vector machine. What is this? Basically, the support vector machine, I told it's a classification algorithm. It's a classification algorithm. Now you might be wondering, sir, we have gone through what to say, linear regression problems. Okay, when we are actually working on a regression part. Okay, when we are working on logistic regression, we covered classification. When we are working on random forest, we covered classification. When we are working on decision tree, we covered classification. Okay, logistic regression also the same thing. Okay, so similarly here also, support vector machine is basically what? It's a classification algorithm. It's a very powerful classification algorithm. Okay. Here you have to know few concepts, and those are basically what? Those are basically what is margin and what is hyperplane. What is margin and what is hyperplane basically. Okay, what is margin and what is hyperplane. लॉजिस्टिक रिग्रेशन याद है सबको? भूला नहीं, उम्मीद करते हैं कोई भी? Hope so nobody has forgotten logistic regression.
No sir.
No. What was actually logistic regression said basically? Just have a look. It's something like this, a sigmoid. Okay, sigmoid. And this was actually the formulation, 1 upon 1 plus e to the power minus theta tx. And what is actually theta tx? Theta tx is basically z. Z. And what is z? Z is the sigmoid. The sigmoid. Okay, so this is basically z. See, z equal to theta tx. So this one, this distance. The value is between 0 and 1. This one. Right? Now, if y equal to 1, we want h theta x should be equivalent to 1, or theta tx should be greater than 0. Okay. Now, if y equal to 0, then the formulation should be something like this: h theta x should be equivalent to 0, and here the value should be equal to 0. Now, it should be less than 0. Alternative view of logistic regression, this was basically when we combined the cost of both. When we combines the cost of both. Okay. So if we look at the close approximation of logistic regression, we can find out the SVM computational advantage. SVM computational advantage. And what is this SVM computational advantage? SVM का computational advantage क्या है? ये लाइन, ये जो लाइन आपको दिख रहा है ना, ये पिंक कलर का जो लाइन है ना, ये लाइन बेसिकली यहां से हमको एसवीएम का क्या मिल रहा है? वी आर गेटिंग द कंसेप्ट ऑफ एसवीएम ओवर हियर. हाउ? बिकॉज एसवीएम बेसिकली divides or it basically classifies. SVM basically classifies on the basis of hyperplane. On the basis of hyperplane, basically. Okay, on the basis of hyperplane. So this line, if we consider this as the hyperplane, then we are very close to our SVM computation. So यहाँ से थोड़ा डिफिकल्ट, दिस इज थोड़ा डिफिकल्ट है समझने के लिए राइट नाउ. अभी थोड़ा समझने के लिए थोड़ा सा डिफिकल्ट है, मैं बताता हूँ आपको नेक्स्ट क्या करना. Support vector machine. Logistic regression equal to minimum of 1 upon m and the whole cost function. Okay, the whole cost function. Okay, and अच्छा, ये लास्ट में जो लैम्डा अपॉन 2m जो ऐड किया हुआ है ना, लैम्डा अपॉन 2m j equal to 1 till n theta square j, you know this is actually what? This is actually called regularization. हाँ, रेगुलराइजेशन अभी हमारा इसमें दो एल्गोरिथम्स आ जाता है. एक को कहते हैं लासो रिग्रेशन और दूसरे को कहते हैं रीज रिग्रेशन. ओके, लासो रिग्रेशन जो है वो हमारा L1 रेगुलराइजेशन कहते हैं और रीज रिग्रेशन का हमारा L2 रेगुलराइजेशन कहते हैं. तो लासो और रीज ये मैं आपको बाद में बताऊंगा, ठीक है, हम आपको बाद में बताएंगे. सो ये लैम्डा अपॉन 2m जो है ना, इसी को बेसिकली हम लोग क्या करेंगे, इसी के थ्रू हम लोग एल्गोरिथम को पेनलाइज करते हैं. वी पेनलाइज द एल्गोरिथम बेसिकली. Okay, and that is what called regularization. So I'm not going into regularization right now because I don't want to go into regularization, otherwise that thing will become very highly complex. But I will go into regularization in the second half. Okay, in the second half I will go into lasso and reach. Okay, in the second half I will go into lasso and reach. Getting the point? So this was actually the formulation. Okay, so we have to do what? This was actually the cost for the logistic, and we need to achieve the minimum of this, the minimum for this. Okay, we need to achieve the minimum for this. Very good. Okay, so similarly the hypothesis for SVM also, similar is the hypothesis for SVM also. It's something like this. Okay, where either it classifies the class into 0 or 1. यहां पर भी डिस्क्रीट आंसर लेंगे तो ही हमारा एसवीएम काम करेगा. डिस्क्रीट क्लासिफिकेशन क्लास रहेगा तो ही हमारा एसवीएम काम करेगा बेसिकली. Right? So the same hypothesis for our SVM also, but just have a look. The last part, the penalizing part, is actually changed a bit. There we had lambda, here we don't have lambda. Here we have summation from I equal to 1 till n, the number of data sets, 1 upon 2, summation from I equal to 1 till n, theta square j. Okay, so this is the formula. This is the only change. This is the only change for the SVM. Okay, and here also the theta tx should be greater than equal to 0. Okay, so classification here also for SVM will be either in the form of 0 and 1. Getting the point? Discrete classification. Now the same thing is basically repeated over here. Just have a look. Just try to understand the concept. Now, this is actually called a decision boundary. This is actually called the decision boundary. Mane linearly separable case. Linearly separable case. So can you see here there is one cluster for circle and there is one cluster for cross. Okay, there is one cluster for circle and there is one cluster of cross. But from both the cluster, can you see one cross is in the front, one cross is in the front, and on the other side two circles are in the front. Can you see two circles are in the front? Hello, hello, is it clear?
Yes, sir.
Or is it getting difficult? Aniket, Rakesh telling yes. What about the rest? क्लियर हो रहा है ना कि डिफिकल्ट हो रहा है? ठीक है अच्छा, तो यहाँ पर देखिएगा तो यहाँ पे देखिएगा, यहाँ पर we have one cross in the front and on the other side we have two circles in the front, and through that circle one line is drawn, and through this cross also one line is drawn. Why only through these two circle and through this cross? Because this circle and this cross are termed as support vectors. इसी को support vector कहते हैं, support vector. तो दोनों साइड से हम लोगों ने एक लाइन ड्रॉ किया, तो बीच में क्या मिला हमको? एक स्पेस मिला. We got one space ना? We got one space, right? And through that space, okay, the midpoint is found out, and through the midpoint one black line is drawn. Black line. That black line is called hyperplane. Okay, hyperplane. That black line is called hyperplane, and this hyperplane is the plane which is distinguishing the two classes separately. This hyperplane is the plane which is distinguishing the two classes separately, or this is actually linearly separating the two classes. Otherwise देखिएगा वहां पर एक pink line है. The pink line is also separating class, circle class and what to say, cross class. There is one green line. That green line is also separating the circle class and the cross class. But can we say that the black line is the best line which is separating the circle class and the cross class? Yes or no? Tell me. Yes? Getting the point? No problem?
सर ये ग्रीन लाइन और पिंक लाइन क्या है? मींस ब्लैक लाइन तो हम समझ गए हाइपरप्लेन है, ग्रीन लाइन और पिंक लाइन.
ग्रीन लाइन और पिंक लाइन को मैंने ड्रॉ किया है आपको समझाने के लिए कि देखिए ग्रीन लाइन भी सेपरेटिंग कर रहा है, क्लासिफिकेशन कर रहा है, सेपरेबल, ठीक है, एंड द पिंक लाइन इज आल्सो सेपरेटिंग, बट दे आर नॉट द ऑप्टिमम लाइन. They are not the optimum line.
Okay, sir, got it.
Getting the point? Okay, this is the thing.
Yes, sir.
Yeah. Now see, just have a look at this example. Here the black line is also separating the two classes, and the pink line is also separating the two classes. Now you tell me which is the best?
Black line.
Black line. Okay.
So what
Black
you have
line.
asked?
And which, and how many of you are with pink line? How many of you are with pink line?
सर आप यहाँ पे क्या पूछे? मींस कौन सा हाइपरप्लेन है?
Yes, yes. Which line is actually separating? Which line is best separating? Which line is best separating? The pink line or a black line?
Black line.
Sir, black line.
Sir, pink line, sir.
Black
Pink line.
The pink line.
Rohit, why pink line? Rohit, see, I told you what is support vector, right? Here we can see that three circles together. Wait, let me take a marker. Wait, let me take a marker or highlighter. Let me take. I took one highlighter. So, can you see this circle? Can you see this circle? Can you see this circle? These are the three circles which are together. Okay, which are together. So, if I draw one line from here, Okay, I draw a line from here. Okay, now here on the cross side, this one is actually the support vector. This one is actually the support vector. And can we consider this as the margin? Can we consider this as the margin? Yes or no? Right? This is the margin. So can we consider this black line as the hyperplane, which is passing through the midpoint of the margin? Yes or no?
Yes, sir.
Yes, sir.
Yes, right? So this black line is separating well. And you might be wondering, sir, where is the separation? Here inside you will say that, sir, here inside this cross, okay, let me take a spotlight. Here inside this cross, sir, there is one, one circle inside this cross. Here inside this circle, there are two crosses. So you know what is this? These are basically called outliers. These are basically called outliers. It is called outliers. What it is called? It is called outliers. What it is called? Outliers. So SVM is very good at ignoring outliers. So it will basically ignore these outliers. It will ignore these outliers. Okay, it's going to ignore these outliers. And this line is actually the black line is the actual hyperplane. And this, if you want to draw the black hyperplane, black line is the hyperplane, then here telling there is a parameter what to say, there is a parameter called C. There is a parameter called C. Okay, there is a parameter called C inside when we work with SVM. Okay, when we work with SVM, there is a parameter called C. What is that C parameter? The C parameter is basically, it is called a penalty parameter. Okay, it's called penalty. Getting the point? It's called penalty. It's called penalty parameter. Penalty parameter means penalty parameter of the error term. Okay, penalty parameter of the error term. So what is actually the influence of C in SVM? What is the influence of C in SVM? See, the C parameter actually tells the SVM optimization how much you want to avoid misclassifying each training example. Okay, अगर C का वैल्यू बहुत लार्ज होता है तो ऑप्टिमाइजेशन क्या करेगा? It will choose a smaller margin hyperplane. And if the hyperplane does a better job of getting all the training point classified correctly, then it's okay. Otherwise, if the value of C is small, okay, then it will cause the optimizer to took a larger margin separating hyperplane. So which one is good? Larger margin separating hyperplane or narrower margin separating hyperplane? Tell me, which one is good? Large margin separating. Which one is good? Large margin separating hyperplane or narrow margin separating hyperplane? Which one is good? Large margin? Obviously large margin. Yes or no? Otherwise, if we choose a narrower margin hyperplane, then that pink line was going to be the actual point. That pink line was going to be the correct hyperplane. Yes or no? If we choose the narrower margin hyperplane. Got it? Then that pink line would be the actual hyperplane, na? But we are considering large margin hyperplane. That's why we are doing what? We are considering that black line as the actual hyperplane. कौन सा अच्छा है पहले मुझे बताइए. नैरो मार्जिन हाइपरप्लेन अच्छा है या लार्ज मार्जिन हाइपरप्लेन अच्छा है? ये बताइए, क्या समझेंगे?
सर लार्ज होगा तभी तो सर डिफरेंशिएट करने में इजी होगा.
डिफरेंशिएट में इजी होगा. तो लार्ज अगर आपको करना है तो विच यहां से लार्जर मार्जिन कौन सा है? ब्लैक लाइन लार्जर मार्जिन था या पिंक लाइन लार्जर मार्जिन है? कल
सर ब्लैक लाइन.
ब्लैक लाइन. सो लार्ज मार्जिन हाइपरप्लेन करने के लिए हमको सी जो है, सी का वैल्यू, सी पैरामीटर जो है एसवीएम के अंदर जो पैरामीटर सी आता है उसका वैल्यू जो होगा, ओके, वो स्मॉल होगा. वो स्मॉल होना. अगर सी का वैल्यू ज्यादा होगा तो इट विल कॉज smaller narrower margin hyperplane, and if the value of C is if the value of C is large, then it will cause narrower margin hyperplane, and if the value of C is not large, then it will cause wider or larger margin hyperplane. तो क्या सीखा हम लोगों ने? C का वैल्यू क्या होना चाहिए? लार्ज होना चाहिए, स्मॉल होना चाहिए? So value of C should be small. Value of C should be always small. Getting the point? Always small. The value of C should be. Okay, the value of C should always be small. What's the point? It should be always be small. Smaller Okay, smaller the value, okay, smaller the value of C, correctly it is going to classify. Why? Because smaller value of C will create a hyperplane with the largest margin, okay, with the largest minimum margin. Getting the point? And the hyperplane will correctly separate all the instances as possible. But if we create a smaller or larger value for C, if we have a larger value for C, it might not differentiate. Okay, it might not differentiate. Okay, so we have to basically means do what? We have to basically see the value. Okay, see the value, which value of C is best. Okay, right? We have to see using the what C value the classifier learns basically best. Okay, on what value of C the classifier learns best. That is basically what we call as the optimization, the SVM optimizer. The SVM optimizer. Okay, clear till here or not? थोड़ा टिपिकल है लेकिन आप समझ जाइएगा, ठीक है। पीपीटी में थोड़ा लिमिटेड नॉलेज रहता है ना, मैं कुछ आर्टिकल्स वगैरह आपको मैं शेयर करूंगा बेसिकली, ठीक है। पीपीटी में थोड़ा मैंने लिमिटेड रहता है, आई कैन अंडरस्टैंड, गेटिंग द पॉइंट। आई एम जस्ट शेयरिंग वन आर्टिकल, मेरे पास एक आर्टिकल है जरूर, ऐड वन आर्टिकल, वन एसवीएम आर्टिकल बेसिकली। Don't worry. Okay, no problem. Let me share one. Just a second. Don't worry. Don't worry. I have that. What happens basically? Let me share. First of all, let me share this. Okay. Let me share. Give me 2 minutes, please. Okay, I shared this k-means and yeah. Just have a look at this particular example. Just try to have a look. This was actually a tutorial. This will actually help you understand. Okay, this will actually help you understand. Basically, just have a look. Now, I told you now which are the support vectors over here. Just have a look. These two green balls and that one red ball. These two are the support vectors on the basis of which this hyperplane is getting drawn. Okay. Now, just have a look at the second example. Here you have to identify the right hyperplane. Okay, we have got the three hyperplanes, that is A, B, C, and all are actually classifying. No? All are actually classifying well. Just have a look. A is also classifying, B is also classifying, C is also classifying. So which is actually the right hyperplane? Can you tell me? Which is the right hyperplane?
Sir, B.
B is the right hyperplane. B is the right hyperplane. Okay, B is the right hyperplane. Now, we know B is the right hyperplane. Now just have a look at this. Just have a look at this. This is also simplifying well. This is also simplifying well. This is also simplifying well. All A, B, C. So which is the right hyperplane?
Sir, C.
C.
C is the right hyperplane. Why? Why, Darshan? See, here it is considered C. If you consider the first two red balls as the as the support vector, and here one star as the support vector, and we draw two lines to create a margin or maximum margin, okay, and this is C is the actual hyperplane. C is the actual hyperplane. C is the actual hyperplane. So the distance is actually called the margin, and here C is the hyperplane. Okay, so hyperplane C is as high as compared to A and B. So here C is actually the hyperplane which will give us the maximum classification, or maximum there is a chance of no misclassification, right? With C there is a chance that there will be rare misclassification, right? Now, rare misclassification. Now, here identify the right hyperplane, B or A.
B, sir. B.
Sir, B
No.
it will be.
No.
No, sir. Sorry, sir. A, sir, because two stars are there. Yes, sir. Sir, A.
Yes,
A.
sir. Yes, sir.
Some might think that sir B is the hyperplane, but it's not like that. See, first two stars, the star over here. Wait, let me take one highlighter. Okay, take one highlighter. This star, okay, and this star. These two are the support vector, and here this one. This red is actually the support vector, right? So if we consider these three, then we draw this hyperplane A. So A. Okay, therefore the right hyperplane is basically A. Yes or no? Very important. It's not that easy. Not that easy. Okay, it's very typical thing we are doing. Okay, now this was actually linear data set. Very good. Linear data set. Linear. Now just have a look at this. Now have a look at this. The first example, and the same example has been repeated over here. Just have a look at this. Now you will say, sir, here it is getting classified, but one misclassification is there. One star is actually inside this red one. So this is, I told you, this is actually called outlier. This is called outlier. And SVM algorithm.
We will note this star also.
No, this will be basically counted as a see from a
outlier.
See, this, yeah, outlier. Why I'm telling you? Because this star has moved from a higher dimension, lower dimensional space to a higher dimensional space. It has moved from a lower dimensional space to a higher dimensional space, and the particular object, if it moves from a lower dimensional to a higher dimensional, will be considered as outlier. Getting the point?
Yes, sir.
Yes, and I told that SVM is very strict with outliers. So here in this, see, for the star from its lower dimension it has moved to a higher dimension, right? Means this will be ignored. Here in this particular scenario, this star will get ignored. It will not be counted. SVM doesn't count this. Okay. Now, how to find the hyperplane to segregate the classes? See. So this was very linear data set. So these are very easy. These are very, very easy. Linear data set. But suppose you have a non-linear data set, something like this. You have a non-linear data set, something like this. Okay, you have a non-linear data set, something like this. Having some non-linear data set. You are having some non-linear data set.
Sir, we need to separate them by using multiple lines.
No, not by using multiple line. We will separate it using by a single line itself. We will separate it by single line itself. Okay, but not in a way, but it will be something in a different way, you know. It will be in a different way, not like this. Not like this. Okay, it will be separated in some other way. This is a non-linear, so it will be separated in some other way, non-linear. Non-linear. Okay, so SVMC, this is a non-linear data set, non-linear data set. Okay, now SVM can solve this problem easily. It solves it by introducing additional feature, and this feature is actually called kernel trick or kernel feature. It is called kernel feature. We have to take another axis. That axis is actually called the z. Z equal to square of x plus square of y. Z equal to x square plus y square. See, z equal to x square plus y square. So if here we have plotted x and y, na? So it was non-linear. Now if we take z as x square plus y square, then one thing we understand that z can never be negative. Z can never be negative, right? So if we plot x and z instead of x and y, because previously it was x and y, it was something like this, non-linear. But when we plot x and z, okay, instead of x and y, will we get something like this? Yes or no? Tell me.
Yes, sir.
We are plotting x, z. Remember, previously it was plot x and y. It was in the round format, and now we are plotting x and z. The z is actually the square of x and y. It is the sum of square of x and y. So z we are getting something like this. On the z axis we are plotting this. So now this data set has actually become linear from non-linear, and now we can easily separate with a single line, right? So from here we can understand few things, that for always the value of z will be positive because it is the squared sum of both x and y. And in the original plot, a red circle appear closer to the origin of x and y axis, leading to the lower value of z, and star relatively away from the origin, resulting to the higher value of z, right? Higher value of z. Okay, because z is actually the square of x and y, so the value of z will always be greater than x and y, right? Now this is actually called SVM kernel trick. This is actually called SVM kernel trick. SVM kernel trick. Okay, and SVM kernel trick is actually applied to solve what? It is used to solve non-linear separation problems. Non-linear separation problems. Basically, it is used to solve non-linear separation problems. Getting the point?
Yes, sir.
Okay, non-linear separation problems. Okay, no problem. Okay, so this is very good thing. Now you might be wondering, sir, what is actually this kernel trick and why it is important? See, basically I'm telling you a few things. Okay, if you see that image, if you see this particular image, okay, if you see this image, previously it was non-linear, means it was non-separable, and now it has become separable. Means the data has actually moved from a lower dimensional space to a higher dimensional space in 3D dimension, something like that. Can we say that? Means it actually allows us to operate on original feature space. Getting the point? The data has actually moved from a lower dimensional space to a higher dimensional space. Yes or no? Means it has moved from a non-separable problem to a separable problem. It has moved from a non-separable problem to a separable problem. Getting the point? Right? It has moved from a non-separable problem to a separable problem. Yes or no? Getting the point?
Yes, sir.
Okay, so SVM kernels are basically of lots of SVM kernels are there. Lots of SVM kernels are there. Okay, lots of SVM kernels are there. Getting the point? So what are basically those SVM kernels? What are those? Basically those SVM kernels, the examples. Okay, the examples I have basically written over here. See, I would like to show it to you. See, linear, non-linear, polynomial, radius basis function, and sigmoid. Okay, sigmoid. So these are basically what? These are actually the type of kernels that SVM use. Okay. In machine learning, SVM kernel, there are different kernels, such as linear kernels are there, non-linear are there, polynomial are there, Gaussian kernels are there, radial basis functions are there, sigmoid function is there, etc. Lots of things are there. Okay. Now, how to select the support vector machine's kernel? How to select that support vector machine kernels? Okay, means which kernel to select? Which kernel to select? Suppose I'm giving you an example. Okay, let's assume the iris flower dataset. So it has got three classes. So if we see that iris flower dataset, it looks both like linear and RBF kernel SVM, radial basis, where we are having more than one classes, right? Where we are having more than one classes, right? Where we are having more than one classes. Now major kernel functions or the major kernel functions in using. Okay, first of all, I would like to tell you about the linear. So from the linear only you can understand that when we have a linear data set, basically, okay, when we have the linear data set, we can basically use the kernel, SVM kernel, as the linear, right? As the linear. When we have a non-linear data set, we can go for a non-linear decision boundary, right? What is linearly separable? Linearly separable, first examples I told you. What are non-linearly separable? The last example that I showed you are non-linear separable. Okay. So when to use this SVM RBF kernel? RBF kernel is a popular because you know why? Because of its similarity to k nearest neighbor algorithm. Means it has the advantage of k nearest neighbor. What it is? Means space complexity. It has the ability to overcome space complexity problem. Okay, because RBF kernel in support vector machine just need to store the support vectors during training and not the entire data set. That's it. Getting the point? Clear, right? Getting the point, everybody? Is it clear or not? Here you have to think a bit, because SVM is a bit typical. Okay, when we are using kernel, that means one thing you should take into account. When we are using kernel, just try to listen to my words. Kernel plays a vital role in classification. It is used to analyze some patterns in the given data. So it is very useful in solving non-linear problem by using a linear classifier. Okay, when we are using kernel, means you are trying to solve a non-linear problem by using a linear classifier. So SVM using kernel trick for transforming the data points means kernel actually helps to deal with high dimensional data in an efficient way. because kernel actually transforms the data from a non-linearly separable to linearly separable. As you saw in the last example, means it is actually moving the data from a lower dimensional space to a higher dimensional space, means from a non-separable part to a separable part. Okay, from a non-separable part to a separable part, right? You came to know about what is hyperplane. So with the help of a hyperplane, you can basically separate the data when it moves from a lower dimensional space to a higher dimensional space, right? Right? No problem with this. Till here it is okay, na? It is okay, na? No problem. Now, yeah, now. Yeah. So SVM algorithm basically takes care of by using this kernel technique. Means the kernel is the best function which takes low dimensional input space and transforms it into a better dimensional. Okay, means it converts non-separable problem into separable problem. So it helps us to deal with non-linear separable problems. Okay, so lots of kernel functions are there. Okay, the most important kernel function which is highly popular is basically the RBF, radial basis function. Radial basis function. It is the most preferred kind of kernel function in R is RBF. Okay, why? Because it is localized and it has a finite response along the complete x-axis, right? So RBF function actually it returns the scalar product between 2 points. It returns the scalar product between 2 points. There is some linear also. What is linear? Linear I don't need to explain. See, here is the example. See, here I have written linear. Here it is linear, written na? Linear. So what is actually linear? It is the most basic type of kernel. That is basically, it is usually one dimensional in nature. Okay, when we shall use it? It shall be used, okay, when it performs the best when we have a lot of features. When we have a lot of features. Okay, so this is basically preferred for text classification. Text classification. Why? As most of these kinds of classifications are linearly separable. Text classification. Text classification. Now we will consider, sir, after that you have written, sir, a non-linear, or you will consider, sir, polynomial. What is polynomial? See, it is also a most generalized representation. Okay, it is not at all preferred, as this is not at all efficient and it is not at all accurate. So don't prefer polynomial. Okay, and the next is we have the RBF, radial basis function. So it is the most preferred and used kernel function in SVM because it is usually chosen for non-linear data set, and this is the RBF kernel which basically makes proper separation or the separation with highest accuracy. Okay, when we don't have the knowledge of the data. Means do you have whether it is a non-linear data or linear data? So where there is no prior knowledge of data, then we basically use RBF. We basically use RBF. Okay, and when we use RBF, okay, so here the value of, there is one more parameter in RBF, and the parameter of RBF is basically called what? In RBF there is a parameter. RBF there is a parameter. There is a parameter called गामा, और ये गामा का वैल्यू जो रहता है ना, गामा वैल्यू लाइज between 0 and 1. Gamma value lies between 0 and 1. The value of gamma basically lies between 0 and 1. Okay, and sigmoid is actually preferred for neural network. Basically sigmoid is basically preferred for neural network. वो neural network का activation function है. Activation function मतलब न्यूरॉन को एक्टिवेट करता है. ओके, न्यूरॉन्स को एक्टिवेट करना है. तो सिग्मॉइड हमारा अब टास्क में है ही नहीं, तो सिग्मॉइड में हम लोग जाएंगे नहीं, लेकिन मैंने आपको बता दिया. आई जस्ट टोल्ड यू एक्चुअली. Getting the point? Clear? So this is actually what we call as SVM and its kernel. SVM and its kernel. Got it? What is actually the kernel basically? Okay, hope so. I have made it clear to everybody. Okay, so that's the thing. No issue. चलिए, तो ये जो है ये बेसिकली मैं आपको दे देता हूं। ओके, SVM, आई एम गिविंग यू दिस SVM. ओके, so okay, I'm giving you this SVM. Now wait, SVM मैं आपको दे देता हूं यहाँ पर. Right, I'm giving you the tutorial, so you study this tutorial. Okay, SVM and I'm giving you one more data set. This data set, actually, you know what it is. It is of apple and orange. It's a very typical small data set that I'm showing you. Okay, apples and oranges. The data set is of apple and orange. I will show you this data set, don't worry. Okay, so right now we have done this. Leave it as it is. Okay, we will look into this. Now I will show you one data set. Okay, data set is of apple and orange. Apples and oranges. This data set, apples and oranges. This data set I actually gave you. It has got three columns. One is the weight, the other one is size, and the third one is class. So it's got 69 is the weight, 4.39 is the size, and class is actually orange. And basically it's a smaller data set. Okay, so we have to classify basically whether it is an apple and an orange, whether it is apple or whether it is orange. Basically, getting the point. So see, these are the weights, these are the size, these are the size, weights and size. Okay. Just have a look at this data set. I'm giving you a time of 1 minute. Okay, saw the data set. Any doubt with the data set? Any problem with the data set? No problem, na?
No.
So we are going to apply SVM on this. हम लोग इस पे SVM
Sir.
yes, please tell me. हेलो, बस कोई कुछ बोल रहा था? ठीक है, सो ये रहा हमारा थ्योरी पार्ट। अभी मैं काम करता हूं, पहले अटेंडेंस में ले लेता हूं आप लोगों का। ठीक है, वो ज्यादा जरूरी है। प्लीज डोंट लीव एनीबॉडी। लेट मी टेक द अटेंडेंस फर्स्ट। टुडे 22nd ना? अच्छा, अनुषा बेरा, अनुष्का बेरा।
Yes, sir.
ओके, जैद सिद्दीकी, जैद सिद्दीकी, श्रेष्ठ पोद्दार, श्रेष्ठ पोद्दार। ओके, सृष्टि बोस, सृष्टि बोस।
Present, sir.
ओके, आदित्य नारायण दास इज प्रेजेंट। चलिए, भावातोष सरकार
Present, sir.
ओके, बुधा, बुधा, बुधादित्य
Present, sir.
बुधादित्य इज प्रेजेंट। वेरी गुड। देवज्योति साहा, देवज्योति साहा, देवज्योति नहीं, अच्छा, देवोपम दास, देवोपम दास। ओके, दीपान खटुआ तो नहीं है। अच्छा, दीपी, अच्छा देवोपम दास प्रेजेंट আছে, দাঁড়াও 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 দাঁড়াও, देवोपम दास प्रेजेंट। अच्छा, दीपी रंजन इज प्रेजेंट, ईमान कल्याण एब्सेंट, कौशिक देवनाथ, कौशिक देवनाथ
Present, sir.
ओके। अच्छा, प्रतीक सेठ, प्रतीक सेठ, प्रतीक, प्रतीक एब्सेंट है। अच्छा, प्रतीक्षा घोष, प्रतीक्षा घोष प्रेजेंट। ओके, प्रत्यय, प्रत्यय इज प्रेजेंट।
Yes, sir.
ओके, प्रयास इज आल्सो प्रेजेंट। ऋषिन हलदार, ऋषिन हलदार प्रेजेंट। रोहिश रे, रोहिश रे
Present, sir. Present.
ओके। रूपम सरकार ओके। संचिता दत्त
Yes, sir. Present, sir.
ओके। सप्तर्षि सेन, सप्तर्षि सेन
Present, sir. Present, sir.
प्रेजेंट। अच्छा, सायन चक्रवर्ती, सायन चक्रवर्ती इज प्रेजेंट। ओके, शेफालिका, शेफालिका प्रेजेंट है, ठीक है। अच्छा, सौमिक कुंडू तो नहीं आया होगा, सौमिक कुंडू एब्सेंट है। अच्छा, शुभम चौधरी है, शुभम चौधरी
Present, sir.
ठीक है। सुमन ठाकुर, सुमन ठाकुर, सुमन ठाकुर, सूर्यदीप रॉय, सूर्यदीप रॉय,
Present, sir.
सूर्यदीप रॉय इज प्रेजेंट।
Yes, sir.
त्रिदीप्त আছে, त्रिदीप्त, त्रिदीप्त মন্ডল, হ্যাঁ त्रिदीप्त আছে, ঠিক আছে, त्रिदीप्त আছে। आनंद मोहन झा, आकाश तो प्रेजेंट আছে, आकाश, आनंद मोहन झा ओके 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 प्रेजेंट, प्रेजेंट। অঙ্গনা দাস, অঙ্গনা দাস
Akash, sir. Present, Akash Cherarjee.
হ্যাঁ আকাশ প্রেজেন্ট, আকাশ প্রেজেন্ট আছো ভাই, প্রেজেন্ট আছো। হ্যাঁ দেবজ্যোতি সাহা, তো দেবজ্যোতি সাহা দাঁড়াও, দেবজ্যোতি সাহা, দেবজ্যোতি সাহা, দেবজ্যোতি সাহা প্রেজেন্ট তো আছো, দেবজ্যোতি সাহা প্রেজেন্ট আছো। আচ্ছা, অঙ্গনা দাস আছে, অঙ্গনা দাস। রূপম তোমার প্রেজেন্ট আছে, ডোন্ট ওয়ারি, রূপম প্রেজেন্ট। অঙ্গনা দাস নেই, ওকে। অনিকেত মিশ্রা, অনিকেত মিশ্রা
Yes, sir.
ओके।
Yes, sir.
অরিন্দম সিংহ, অরিন্দম সিংহ
Yes, sir. Yes, sir.
ओके। অরিত্র ঘোষ
Yes, sir.
वेरी गुड। अर्णब चक्रवर्ती तो नहीं, अर्णब चक्रवर्ती तो नहीं। अरविंद कुमार मिश्रा प्रेजेंट। आयुष मिलन इज आल्सो प्रेजेंट। बिलाल अहमद, Bilal Ahmed. Bilal Ahmed. Okay. Darshan is present. Gargi is present. Jit Saha present.
প্রেজেন্ট স্যার।
হ্যাঁ, মেঘা পল আছে? মেঘা
হ্যাঁ স্যার আছি।
আছে। মোহিত সাহাল আছে। নিখিল কুমার।
Yes, sir.
ওকে। पंकज घोष।
Yes, sir. Pankaj Ghosh.
ओके। प्रभात कुमार।
Present, sir.
ओके। राकेश रोशन इज प्रेजेंट। रेशमी इज प्रेजेंट।
Yes, sir,
Okay.
Yes, sir.
present.
Present, sir.
Okay, 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 present. Both are present. Rohit present.
Yes, sir, present.
रोहित रौनक प्रमाणिक एब्सेंट। संजना रानी। संजना रानी प्रेजेंट है। ठीक है। अच्छा, सप्तर्षि कुंडू है? सप्तर्षि कुंडू नहीं है शायद। अच्छा, सप्तर्षि আছে? ও বাবা রে, ভালো তো। अच्छा, सप्तर्षि रॉय। सप्तर्षि रॉय नहीं है। अच्छा, राकेश रोशना प्रेजेंट है, डोंट वरी, प्रेजेंट है। सायन बाग।
Yes, sir. Present, sir. Sign back.
ओके। सायनी घोष। सायनी घोष। श्रेय कुमार बर्नवाल। श्रेय कुमार बर्नवाल। ओके।
Present, sir. Present, sir.
ओके ओके। सिमरन कुमारी। सिमरन कुमारी।
Present, sir.
हाँ, ठीक है। स्नेहा गोस्वामी है? स्नेहा गोस्वामी।
Yes, sir, present.
ओके
Sir,
ओके
present.
ओके, ठीक আছে। सोहम भट्टाचार्य है? सोहम भट्टाचार्य नहीं है। सौती सामंतो। सौती सामंतो
Yes, sir,
नहीं है।
present, sir.
अच्छा, ठीक है, प्रेजेंट है। सौरा
Shruti Samanto present. Shruti Samanto
हाँ,
present, sir.
प्रेजेंट प्रेजेंट है, प्रेजेंट है। सौती प्रेजेंट है। ठीक है, प्रेजेंट हो गया है। सौरभ बाग है? सौरभ बाग नहीं है। अच्छा, सुभाषिस पॉल है? सुभाषिस पॉल। सुभाषिस पॉल
Present, sir.
सुभाषिस पॉल बहुत अच्छा है। सुधोजित दे तो नहीं आया है, आई थिंक। सुधोजित दे। सुमित कुमार। सुमित कुमार। सुमित कुमार। सूरज माइती। सुमित कुमार।
Yes, sir. Suraj Maiti present.
सूरज माइती प्रेजेंट है ना? अच्छा। वरदान
Yes, sir.
शासक। वरदान शासक। वरदान शासक था,
Yes,
मैंने
sir.
देखा। ठीक है,
Present.
ठीक है, चलिए चलिए चलिए, चलो, थैंक यू थैंक यू थैंक यू। चलो, अच्छा है, ठीक है, ओके, चलो। तो ये हमारा अटेंडेंस रह गया। चलिए, अच्छा बात है।
हेलो सर।
हाँ हाँ, बोलिए, नेक्स्ट बोलिए।
বলছি স্যার, বলছিলাম কালকে আমি এই আমার নেটওয়ার্ক প্রবলেম ছিল, কালকে লাস্ট হাফটা আমি অ্যাটেন্ড করেছিলাম, ওটা
কি নাম আছে বলো?
পেয়েছিলাম।
কি নাম আছে বলো?
सूर्यादीप
ঋদ্ধিমান
रॉय।
ঘোষ প্রেজেন্ট है? ঋদ্ধিমান ঘোষ প্রেজেন্ট, অলওয়েজ প্রেজেন্ট। ঋদ্ধিমান ঘোষ, তোমার নাম বলো কি আছে?
सूर्यादीप रॉय।
বলো।
हेलो सर, सूर्यादीप रॉय। सूर्यादीप रॉय। हाँ।
दाड़ा। सूर्यदीप रॉय। सूर्यदीप रॉय, वेट 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 वेट। सूर्यदीप रॉय, सूर्यदीप रॉय, सूर्यदीप रॉय, सूरज माइती, सूर्यदीप रॉय। नाम कहाँ है? सूर्यदीप रॉय। काल के ना, काल के, हाँ चलो हो गए, चलो ठीक है।
Sir, sir, আমারও কালকে
ত্রিদীপ্ত মন্ডলও
नाम
ছিল।
बोलिए, नाम बोलिए, नाम बोलिए।
স্যার গার্গী দেব না, সেকেন্ড হাফে আমারও নেটওয়ার্ক প্রবলেম হচ্ছিল।
अच्छा, गार्गी देवनाथ, ओके।
ত্রিদীপ্ত মন্ডল।
त्रिदीप्त मंडल, ठीक है। त्रिदीप्त তুমি তো প্রেজেন্ট আছো।
কালকেও ছিলাম সেকেন্ড হাফে স্যার, নেটওয়ার্ক প্রবলেম
কালকে
ছিল।
ছিলে? দাঁড়াও, ত্রিদীপ্ত তুমি তো প্রেজেন্ট আছো কালকে সেকেন্ড হাফে।
ওকে স্যার, ওকে।
ঠিক আছে। গার্গী দেবনাথ, দাঁড়াও। গার্গী দেবনাথ, দাঁড়াও, ওয়েট করো, ওয়েট করো। গার্গী দেব, গার্গী তুমি তো প্রেজেন্ট আছো সেকেন্ড হাফে কালকে।
না স্যার, সেকেন্ড হাফে না প্রচন্ড নেটওয়ার্ক প্রবলেম হচ্ছিল, সেই
না
জন্য
না,
ঢুকে বেরিয়ে গেছে।
বলে কি হলো, আমার তো ইয়ে আছে তো, আমি তো আবার পরে এটাকে আবার ভেরিফাই করি।
ও আচ্ছা আচ্ছা, ঠিক আছে
ঠিক আছে, আমি এটাকে আবার ভেরিফাই করি গো টু মিটিং এর ইয়ে নিয়ে, ওটা নিয়ে চিন্তা নেই। ঠিক আছে, একদম চিন্তা নেই।
ওকে স্যার।
ওকে, ডোন্ট
Hello, sir. Sayani Ghosh.
शायनी घोष, रुकिए
हाँ, सर।
शायनी, रुकिए रुकिए शायनी, शायनी घोष, शायनी घोष, शायनी घोष आप शायनी घोष, शायनी घोष आप तो प्रेजेंट है, आपका तो हर दिन प्रेजेंट है शायनी घोष।
স্যার আজকের জন্য এই হ্যাপের আমার
नहीं आज को
এখন जो
मैंने प्रेजेंट कर दिया आपको, शायनी घोष প্রেজেন্ট করে দিয়েছি আমি, চেক করলাম যেখানে গোটু মিটিং আমার রিফ্লেক্ট হচ্ছে তো শায়নি ঘোষ প্রেজেন্ট আছে।
আচ্ছা স্যার,
ঠিক আছে, তোমার অল डे प्रेजेंट আছে शायनी, डोंट वरी। ओके राकेश रोशन, आप एकदम चिंता मत करो भाई, आप एकदम 100% प्रेजेंट हो, आप एकदम टेंशन मत लो, ठीक है। टेंशन मत लो एकदम। ओके चलो ठीक है, आज और कुछ कराएं या इतना रहने दे अभी के लिए? आई थिंक अभी इतना रहने देते हैं। क्या बोलते हैं आप लोग? ये डेटा सेट मैं आपने को दे दिया हूं, ये डेटा सेट को रखिए, सेकेंड हाफ में मैं इसके लेकर एक व्हाट टू से आई विल गो फॉर एसवीएम, ठीक है, आई विल गो फॉर एसवीएम, क्योंकि हड़बड़ी में तो करने से कोई फायदा है नहीं, राइट, यस और नो? ठीक है, अभी आपके लिए कोई डाउट है, कोई क्वेश्चन है तो बोलिए हमको, कोई डाउट क्वेश्चन है तो उसको सॉल्व कर देंगे, अदरवाइज कोई दिक्कत नहीं, नो प्रॉब्लम। चलो चलो अभी इतना ही रहेगा, चलो ठीक है।